learners, we are going to study about motion in a straight line. So, let us start with what is motion. Suppose I consider an example. Let us say this is a pen in my hand and right now it is at this position, right. Now, suppose it moved to this position. So, we can say that with the passage of time, the body has moved from this place to this place, and this is what called motion. So, we can say that when the body moves with the passage of time, the body is said to be in motion. So, there are various examples around us where we can see, where we can observe motion. For example, when we are walking, when we are moving in some vehicle, even if when we are sleeping, so our lungs, the air goes in and out through our lungs. Even our heart, it pumps the blood through our veins and arteries. So, this is also motion. Even we know we have the day and night. So, the earth is rotating around the sun, around its own axis. That is also motion. The earth revolves around the sun in 1 year, and that is also, we can say, earth is in motion. Even the sun, which is we consider that sun is at rest, even the sun is continuously in motion in its own galaxy. So, these are some examples which we can see, and according to which we can also consider that all the things around us are in actually motion. How do we define motion? So, motion is the change in position with time. So, we study about motion in the branch of physics called kinematics, and kinematics is defined as the study of motion without considering its causes. So, here in kinematics, initially when we will study about motion, in this chapter we will confine our studies just to the motion of the object while the object is moving, but will not talk about the cause of the motion. Also, in this chapter we will talk about only the straight line motion, that is also known as a rectilinear motion, in which we consider the motion moving along the straight line. For this we can consider the example, for example, the apple falling from the tree. So, what is the path of the apple when it falls from the tree? It is a straight line path. Similarly, we can consider suppose a train is moving on the straight track. So, what is it? It is the motion of the train along the straight path. So, in this chapter we are just going to confine our examples, we are just going to consider the motion along the straight line. So, let us talk about the meaning of this term point object first. If we can ignore the size of the object compared to the length of the path it travelled, then we consider the object to be the point object. So, for this I take some examples. Suppose a train which has a length of, let us say, 200 meters, it travels a distance of 50 kilometers between the two different cities or two different towns. Then the size of the train or the length of the train can be ignored, because the size which I consider 200 meters, that is of train, is very much smaller with respect to the distances travelled between the two stations, right. Then we can consider the size of the train to be as a point object. I will consider one more example. Let us say the size of the earth when it is moving in the galaxy. So, the size of the earth can also be ignored when we consider its motion in the galaxy. So, because the distance it is going to travel is much bigger with respect to its own size. So, this is how we can ignore the size of the object, and the purpose is just to make our calculations, make our equations simpler to describe motion. That is the only purpose. So, now again coming back to the same question, can a train of length 200 meter crossing a platform 500 meters be considered as a point object with respect to the platform? Of course not, because here the length of the train and the length of the platform are comparable. It cannot be ignored. The size of the train cannot be ignored here, because 200 meters and 500 meters there is not much difference. So, this is how we consider point object. Now, to describe the motion, we need to consider the position of the object. So, now let us see. you can see one picture over here where a dog is sitting, So, to describe its position, I need some reference. With respect to which I will determine, or I can consider whether the object is at rest or in motion, and actually what is its position. So, here if you see, if I consider the swing as a reference, then with respect to it, this is the position. This is the position. So, the distance between the object, that is this dog, and the swing is actually describing the position of this dog. And also with the span of time, with the passage of time, if this position is not changing with respect to the swing, then we can say the dog is at rest. Now, look at the another situation. Here, the same example I have taken, but now just compare the two pictures. Here, the position of the dog with respect to swing in this figure is towards the left. So, this is the position of the dog with respect to this swing. Now, look at the other picture. Now, here if you look at the position of this dog with respect to the swing, you will see that the position has changed now. So, we can conclude from here by referring the position of the dog at different times with respect to the swing, that this dog is in motion. So, here we see that the importance of the position, in describing the motion of an object. Now, I consider another example. Here we have seen that the same object is in rest or in motion. Now, let us see that how the motion is relative. I mean to say that nothing is at ultimate rest or at ultimate motion. Motion is always relative with respect to its surroundings, we can say, whatever reference we have taken, with respect to whatever reference we have taken. For this I consider one more example. Suppose I consider this bus, in which I consider that the two persons, let us say A and B, are sitting in this bus, and one person, let us say person C, is standing somewhere outside on the let us say on the platform, right. So, now the motion of the bus is, let us say, is in this direction. The two passengers A and B, which are sitting inside the bus, they both are at rest with respect to each other. I mean to say, if this person A will look at B, for him B is at rest. Similarly, for B, this A is also at rest, because they both are sitting in the same bus which is moving. So, they both are moving with the same speed in the same direction. For each other, they both are at rest. Now, consider another person who is C, standing somewhere on the ground outside the bus. So, for this person C, both this A and B are in motion, right. So, this person C is at rest, standing on the ground, but for him A is in motion, for him B is also in motion. So, there is a role of reference, importance of reference here. Suppose if the reference is A, for B, then they are at rest, but now for C, the A is in motion. So, that is how we can say that no body or no object can be at ultimate rest or at ultimate motion. Motion is relative. It depends upon with respect to what reference we are talking about. Now, for our convenience, we consider as a reference frame as the three mutually perpendicular axes which are intersecting at a point O, and this point O is called the reference point or the origin of the reference frame. Now, these are x axis, y axis and z axis. These three axes are mutually perpendicular and intersecting at point O, which is termed as the origin. Now, suppose a particle is at this location, particle represented by P. Now, the position of this particle can be described in this reference frame with the help of the coordinates, with the help of x, y and z coordinates. So, for that what we do, we just drop the perpendicular on x axis from that particle position, and this length gives the x coordinate of the particle. Similarly, we drop the perpendicular on y axis, and this length gives the y coordinate of this particle. And similarly on z axis, so this will be actually the z axis because it is perpendicular to the plane, either outwards or it can be inwards. So, when we drop the perpendicular of this particle, when we drop the perpendicular from this particle on z axis, we get the z coordinate. So, this is how we specify the position of the particle in any reference frame. In this chapter, since we are confining our discussion to a straight line motion, so only one of the axes can serve the purpose of reference frame. So, here we can see that this is one of the reference frame which I have considered, which is describing, which may describe the motion along the x axis. So, it does not mean that the motion can be along x axis only, it can be along y axis also. It can be along z axis also, z axis I mean to say outward or inward, say board, with reference to this board if I talk about. Also we can describe the motion in a straight line as right and left, or up and down, or inwards and outwards. So, it is all our choice what we consider. Now, here if you see in this reference frame, I take one point as the origin. So, here if you see, this is the origin which is marked as O and labeled as 0. And then I distribute this complete axis, which is I have considered along x axis, in equal divisions, and marked it as distance in meters, because maybe if I require some motion which is covering the distance in meters in some specific time duration. So, the scale can be like 40, 80, 120, 160 and so on meters in the plus direction, or on the other side the direction can be considered as negative direction. So, motion is possible in a straight line either with reference to either right or towards the left. Now, here for example, I consider the particle is at any instant at this position q. So, this q, what is the position of this particle when it is at point q? Its position is 240. That is plus 240, it is towards the right. So, it is at 240 meters from the origin, which is a reference point. Suppose the particle is at point P at any instant, then what will be the position? Its position will be 360 meters. Its position will be 360 meters again. Then suppose if the particle is at this position R, then what is its position? Its position is at a distance of minus 120 meters or towards the left of the reference point. So, this is how we describe the position. Now, let us talk about the another physical quantity called displacement and distance. So, first of all I will talk about distance or the path length. So, what is the path length? It is the total length of the path traveled between the two positions. So, we are very much clear about the positions, how to specify the position of the object. Now, let us talk about if the object is in motion, then how do we describe its distance travel, right. So, again I consider the same reference frame and I consider कि suppose an object is initially at the origin, right. Now, suppose it travels, it starts moving, and in a particular amount of time it reaches to this point q, it reaches to this position q, then how much will be the distance travel or what is the length of the path? The length of the path will be finally it has reached to 240 and the actual length of the path will be this measurement of this distance. So, it is 240 meters. Right? It is 240 meters. The length of the path travel or the distance travelled by the object is 240 meters. Now, after reaching to point Q, it moves to point P as well. Then what will be the total length of the path covered? That is 240 till 360. So, it is finally 360 meters will be the length of the path or the distance travelled. There is no plus and minus when we talk about the distance. We just talk about the magnitude. So again, we need to understand this. The distance we need just to consider the magnitude, the quantity which has been traveled. We need not to consider any sign when we denote the distance, right. In position we specify the plus and the minus sign with reference to the origin, but when we talk about the distance, we are not concerned about the sign. We just need to go on measuring the length of the path travel. Now again, after reaching to this point P, the person or that object, it moves in the backward direction, it takes a turn and then reaches to point Q. Now, what is the total distance travel? So, for this what we will do? We will first of all see from the origin, it travelled a distance of 360 meters. So, 360 meters and then what else? It travels this much more distance, So, in this we need to add this distance also. And what will be this distance? This distance will be 360 minus 240. So, we need to add in 360 meter this distance as well. So, can we calculate it? It will be equal to 360 meters plus its 120 meters. So, finally, how much is the distance travel? The distance travel will be 480 meters. So, this is the total distance travelled by the object when it starts from point O, reaches to Q, then to P and then come back till point Q. So, this is the actual length of the path it travelled. Now, suppose it starts from, I take another situation, the same object starts from point O, reaches to point P and then returns back to point O. Now, what will be the total length of the path? So, for that what we are going to do? We are going to first of all consider the length this much, that is 400 meters. If it reaches to another point, I label it as S suppose. S is at a distance of 400 meters. So, it moves from O to S, which is at 400 meters. Again it takes a turn and then again reaches to the origin. So, what is the total length? It will be 400 plus 400 meters. So, finally, what is the total distance travel? The total distance travel will be equal to 800 meters. Now, I take another example. Suppose the same object starts from point O, right, and then it travels towards the rightwards in this direction and just reaches to this point at a mark of 80 meters at point T. Then it takes a turn and moves till the origin, again continue further in the same direction and reaches till a mark of minus 80, Let us say I label it this point as M, this minus 80 mark as M. In this situation, what is the total distance travel? Again, as I told you earlier, we need not to concern about the sign, we just need to go on add up the distances. So, here 80 meters towards the right. So, 80 meters plus it returns back till the origin, again 80 meters plus it moves towards the leftwards, again a length of 80 meters. So, do not consider minus 80. So, it is 80 plus 80 plus 80, that is 240 meters. So, the total distance travelled is 240 meters in this case. So, this is how we measure the path length or we describe the distance travel. Now, let us talk about displacement. In displacement, we talk about the length of the path along with the direction. So, displacement has a direction as well as a magnitude. So, for this again I consider a same reference frame wherein I considered this as the origin and again my reference frame is along a straight line, as we are considering the motion along straight line. Now, this reference frame has both the directions towards the right and towards the left. So, here suppose I consider x1 and x2 to be the position of an object at some two different instants of time, let us say t1 and t2. So, here the displacement is denoted by delta x. So, delta x is a Greek symbol which is used to denote the difference between the two quantities, right. So, the displacement here I am going to denote with delta x, and the time duration, that is the difference in the time, can be denoted by delta t. So, in this case, if I consider that a particle moves from point O, that is from the origin to point P, then what is the displacement? The displacement will be now delta x, and this displacement will be final position minus the initial position. So, now we are going to consider the sign as well, as displacement is a vector quantity. So, vector quantities, vector and scalars in detail we are going to study in the next chapter, but here when we talk about motion in a straight line, we can just consider in terms of the sign plus and minus. So, here delta x between this point P and point O will be, the final position is plus 360, I will consider along with the sign, minus the initial position is 0. So, what is the displacement? Displacement is plus 360 meters, right. Now, I take one more example. Suppose now the particle starts from O, reaches to point Q, and then returns to point O, In that case, how to calculate the distance? We have already seen, that is, we will add 240, then we will again add 240, we get 480 meters as the total distance travel. But now when I need to calculate the displacement, then displacement delta x will be equal to, the particle is returning to the same initial position, then the final position is 0 minus the initial position is also 0. So, what is the displacement? Displacement is 0, there is 0 displacement. So, here you can notice a difference between the distance and displacement. Although in the same example the distance travelled is 480 meters, but the displacement of the same example is 0, right. One more example I take. Suppose the particle starts from point O, right, reaches to some point S, let us say at a distance of 120 meters, then return back to point O and then continue moving in the same direction, and again reaches to a distance of 120 meters, that is at a position R. In this situation, what will be the displacement? So, displacement we need to just focus on two things, that is the final position and the initial position. So, here the particle started from origin only, does not matter, it reaches in this direction also, it travels in this positive direction also, then return back and then goes to the left direction, does not matter. We just need to focus on the final and the initial positions. So, here the final position is this minus 120 and the initial position is O, right. So, in this case this delta x will be equal to, the final position along with the sign we are going to consider is minus 120 minus the initial is 0. So, what is the displacement? The displacement is minus of 120 meter. And in the same case, if I need to consider the distance, what it would have been? 0 to 120 is 120 meter, the length of the path, plus again to 0. So, again 120 add up, then again to 120 on the other side. So, again plus 120 meter, and when you add all the three, what do you get it equal to? You get it equal to 360 meters. Now, see the difference, the distance travelled is 360 meter, whereas the displacement is minus of 120 meter. So, I hope that you understood well the difference between the distance and displacement, how to measure the distance and how to measure the displacement. Now, let us take one example here. Suppose the distance between your home and the school is 3 kilometers, and again for our convenience, since we are considering the straight line motion, this is your home and this is, let us say, your school, right, and the distance the distance between them is 3 kilometers, right. Then what is the distance and the displacement covered in one round trip? So, I believe, I hope that you will be able to find out what is the distance travelled in one round trip. 3 kilometers plus 3 kilometers, that gives you 6 kilometers is the distance travelled. And what about the displacement? Initially you started from home, you go to school, you come back to home. So, both the initial and the final positions are same. So, your displacement delta x will be equal to 0, right. Now, let us take another example. Sakshi rides 3 kilometers east and then turns around and rides 2 kilometers west. Now, what we need to find here? We need to find what is the displacement, what distance does she ride, and what is the magnitude of a displacement. So, again I consider a reference frame, let us say, a simple reference frame with respect to the direction. This towards the right, it is east, and this direction I consider, let us say, west. Now, since the distance travelled is in kilometers, so our reference, the scale will be, I will mention in kilometers, scale in kilometers. I can also divide the scale in equal divisions, both the sides, and let me mark it as 0. This is the origin, then 1, 2, 3 and 4. So, here 1, 2, 3, 4 are specifying the distance in kilometers. Same way here also 1, 2, 3, 4, right. Now, Sakshi rides 3 kilometers due east. So, she rides 3 kilometers in this direction and then returns and rides 2 kilometers west. So, means from here she takes a turn and then 2 kilometers she returns back. So, initial point starting from O, from 0, this is a 0 mark, reaches to 3 kilometers mark and then returns back on 1 kilometer mark in the positive direction only, in the east direction only actually, right. So, what will be the displacement? We can all calculate it. So, the displacement will be final position minus initial position. So, if we consider right side, the east side to be the positive, then this side will be negative. So, since the final position is also lying on the positive side, so here the displacement delta x will be plus 1 minus the initial was 0. So, it is plus 1 kilometers. So, plus 1 will represent 1 kilometer due east, because positive direction is representing east direction. Now, how what distance does she ride? So, for this we need to do the find out the total length of the path. So, the total length will be starting from 0, 3 kilometers plus 2 kilometers. So, that is equal to 5 kilometers, right. This is the total length of the path or the distance she ride. What is the magnitude of a displacement? Right. So, as we see, displacement was plus 1 kilometers. So, when we talk about the displacement magnitude, we just ignore, we just leave the sign. So, it is represented as modulus of plus 1. So, the magnitude is actually 1 kilometers. What is the magnitude? The magnitude will be 1 kilometer. Suppose if it had been minus 2 or minus 3 kilometer, then also it would have been 2 or 3 kilometers respectively. So, this is what, how do we differentiate between the distance and displacement. Now, let us see let's again recall what we have studied. Kinematics is defined as the study of motion without considering its causes. Next, we studied if the size of an object is very small compared to its distance travelled, then it can be treated as a point object. The third point is motion and rest are relative terms. Next is the frame of reference is a set of coordinate axes in which position or motion of an object can be specified. The next point which we studied is in one dimensional motion or the motion in a straight line, there are only two directions, backward and forward or upward and downwards, in which an object can move. Next is the distance travelled is the total length of the path travelled between the two positions. Distance has only magnitude and no direction, whereas displacement is a vector whose length is the shortest distance from the initial to the final position of an object undergoing motion. One more point I would like to add here, that distance is always positive if we, as we have seen, but displacement we have seen it can be positive, it can be negative, it can be 0 as well. But in all the cases we would have observed that displacement can never be more than the distance travelled, right. Now, displacement has both magnitude and direction, and the magnitude of displacement may or may not be equal to the path length traversed by an object. So, this was all for this session. We are going to continue this chapter in the next session.